Mars, the red planet, a desolate world of rusty dust and ancient volcanoes. Today Mars is a cold and dry desert, but it wasn't always this way. Long ago Mars was a very different place, a planet with flowing rivers and vast lakes. Imagine a blue Mars, billions of years in the past. The evidence is compelling. It's written in the very rocks and landscapes of Mars. We see ancient riverbeds, carved by flowing water. We see signs of massive floods that once raged across the surface. The evidence for a watery past on Mars is abundant. It's scattered across the planet's surface, etched into its ancient landscapes. One of the most compelling pieces of evidence is the presence of ancient riverbeds. These winding channels, some stretching for thousands of miles, are the remnants of rivers that flowed billions of years ago. They paint a vivid picture of a time when liquid water flowed freely across the Martian surface. We also see signs of vast lakes and even oceans. Giant basins, some larger than Earth's Mediterranean Sea, show evidence of having once held massive amounts of water. These ancient lake beds often contain minerals and sediments that form in watery environments, further supporting the idea of a wetter past. The presence of these deltas on Mars provides strong evidence that the planet once had large bodies of standing water. Even at the microscopic level, we find evidence of water's influence. Billions of years ago, Mars began to transform. The planet that had been warm and wet with the potential for life began to dry and cool. A process unfolded that stripped Mars of its liquid water, leaving it the desolate world we see today. Early Mars had a much thicker atmosphere than it does today. This thicker atmosphere trapped more heat from the sun, creating a greenhouse effect that kept the planet warm enough for liquid water to exist on its surface. However, over time, Mars began to lose its atmosphere. This loss was driven by a number of factors, including the planet's weak gravity and the solar wind, a stream of charged particles constantly flowing from the sun. As Mars's atmosphere thinned, the planet's greenhouse effect weakened, causing temperatures to drop. The drop in temperature had a profound effect on the Martian water. Section 4. Escape to space, a slow and steady departure. As Mars's atmosphere thinned, its grip on its water weakened. Water molecules, once held by gravity, found a path to escape the planet's pull. This escape to space unfolded gradually, over millions and millions of years, a slow and steady departure that ultimately robbed Mars of its oceans and rivers. Imagine a single water molecule, energized by the sun's radiation, rising high in the Martian atmosphere. The higher it climbed, the thinner the atmosphere became, and the weaker the planet's gravitational pull. Eventually, this tiny molecule reached a point where Mars's gravity could no longer hold it, and it was lost to the vastness of space. This process, repeated countless times over billions of years, had a significant impact on Mars's water inventory. While the escape of a single water molecule might seem insignificant, the cumulative effect over time was substantial. Scientists estimate that a significant portion of Mars's early water, perhaps enough to fill an ocean several hundred meters deep, was lost to space through this process. The escape of water to space was not the only factor contributing to Mars's drying. Section 5. Trapped beneath the surface, ice and groundwater. While a significant amount of Mars's ancient water escaped into space, a substantial portion remains on the planet, hidden beneath its rusty surface. This subsurface water, locked away as ice and groundwater, represents a tantalizing clue in our quest to understand the red planet's watery past and its potential for harboring life. Imagine vast sheets of ice extending deep below the Martian surface, remnants of a time when liquid water flowed freely. These ice deposits, formed as the planet cooled and its surface water froze, hold a record of Mars's ancient climate and potentially even traces of past life. Scientists believe that liquid water may also exist beneath the surface in the form of groundwater. This groundwater, trapped in pores and fractures within the Martian rock, could provide a potential habitat for microbial life, shielded from the harsh conditions on the surface. The search for subsurface water on Mars is a major focus of current and future missions. Section 6. Searching for clues, the role of rovers and orbiters. In our quest to unravel the mystery of Mars's lost oceans, we have dispatched robotic explorers to the red planet, our eyes and ears on this alien world. Rovers, like tireless geologists, trundle across the Martian surface, analyzing rocks, drilling into the ground, and sending back a treasure trove of data. Meanwhile, orbiters circle high above, their instruments peering down to map the planet's surface, probe its atmosphere, and search for signs of water. Consider the Mars exploration rovers Spirit and Opportunity, which landed on Mars in 2004. These twin robots, far exceeding their planned mission lifetimes, roamed the Martian surface for years, sending back stunning images and groundbreaking scientific discoveries. Their observations of layered rock formations, rich in minerals that form in the presence of water, provided compelling evidence for a watery past. From orbit, spacecraft like Mars Reconnaissance Orbiter, MRO, and Mars Atmosphere and Climate Evolution Mission, MAVEN, provide a global perspective. MRO's high-resolution camera, HiRISE, has captured stunning images of Martian surface features, including ancient riverbeds, layered rock formations, and even evidence of seasonal flows of liquid water. Section 7: The Future of Mars Exploration, Water and Life. As we delve deeper into the mysteries of Mars's past, the search for water remains a driving force behind our exploration. The discovery of liquid water on Mars, whether on the surface or below, would be a momentous event. It would have profound implications not only for our understanding of Mars as a planet but also for the search for life beyond Earth. The presence of liquid water would make the possibility of finding life on Mars much more likely. On Earth, where there is liquid water, there is life. It is the life-sustaining solvent essential for all known forms of life. If liquid water exists on Mars, even in small amounts, it could provide a habitat for microbial life. Future missions to Mars will continue to follow the water. Rovers equipped with even more advanced instruments will explore regions of high scientific interest, drilling deeper into the Martian subsurface, searching for signs of past or present life.